I'm starting to record. Yes, so good morning, everyone. Good morning, guys. How are you? Kedi, what does that mean?
You're fine.
Yeah, it can mean anything. So I wanted to be sure. So let me go back here. Last time we began talking about the circulatory system, and we arrived at the components of the circulatory system, which include the heart, blood, and the blood vessels. Not so? Now, I want to first put a highlighter. People should begin reading about genetics because very soon I am introducing genetics on the board. We are going to begin doing all those crosses and all those things. So begin reading about it so that it doesn't get you off guard, okay? Yeah. Now, we are going to talk about the differences between arteries and veins. The first one is arteries have thick muscular walls and they have a narrow lumen. Arteries have no valves. Who is that putting on their camera? You're distracting your friends. They have thick muscular walls. Arteries have thin and less. Veins have thin and less muscular walls. Arteries, on the other side, have a narrow lumen. Veins have a wide lumen. A lumen is that opening inside the artery where blood passes, just like the opening of a pipe. It's not called a hole, it's called a lumen. So arteries have a narrow lumen, while veins have a wide lumen. Arteries have no valves, while veins have valves. Also, arteries transport blood away from the heart, and veins transport blood to the heart. All veins transport blood to the heart. That implies as long as the blood is going in the direction of the heart, that is called a vein. So the other point that I want to note here is that arteries, all of them carry oxygenated blood except the pulmonary artery. The pulmonary artery carries blood from the heart to the lungs. That artery does not carry oxygenated blood. It carries deoxygenated blood. Uh, while all veins carry deoxygenated blood except the pulmonary vein. Okay. In arteries, blood flows at a high pressure. Why does it flow at a high pressure? Because of three things: thick muscular walls, narrow lumen, and blood being that it is coming straight from the heart, it travels at a high pressure. While in the veins, blood flows at a low pressure. And why is that? Thin and less muscular walls allow for blood to flow at its own pace, and wide lumen, meaning that, because remember, pressure is inversely proportional to volume. That means that as volume increases, pressure will decrease. As volume decreases, pressure will increase. Like the arteries have a narrow lumen, which decreases the volume, it therefore increases the pressure. They have thick muscular walls, which maintain a high pressure, and they have no valves. They have no valves, which prevent the backflow of blood, okay? And you're saying in arteries, blood flows in pulses. Why does it flow in pulses? If you touch your neck around near the throat area, you can feel that pumping action. That pulse is as a result of the pumping action of the heart. That's how they test if a person is still alive. If you still have a pulse, it means your heart is still beating, because that pulse is created by the heart pumping. The vein, on the other hand, yes, I can, guys. By the way, I cannot see when you're putting up your hand, so you may have to just unmute yourself. Okay. Someone was saying something. I guess not. We are saying in veins, because there's no pulse, blood flows smoothly. Now, we have the intermediate of the arteries and the veins, and that is the capillaries. I said earlier that arteries divide into smaller vessels called arterioles, and veins divide into smaller vessels called venules. And we're saying capillaries, they are small one-cell thick vessels lying between the cell of every organ. Small one-cell thick vessels lying between the cell of every organ. Small one-cell thick vessels lying between the cell of every organ. Now, what happens is arteries divide into smaller vessels called arterioles, and arterioles further divide into smaller vessels called capillaries. We are going to see what this does. It has an effect on the pressure. And then we are saying capillaries join an arteriole with a venule. They join the arteries and the veins. How are they adapted to do their function? First and foremost, you have to understand their function. Being that they are between the cell of every organ, exchange of materials occurs at the capillary point. Exchange of materials occurs at the capillary point. And we are saying here that capillaries have direct contact with tissues. They have direct contact with tissues for efficient exchange of materials. They have direct contact with tissues for efficient exchange of materials. They are numerous to increase the surface area over which exchange of materials can occur. Numerous, meaning there are very many. Okay. Now we know from earlier in transporting plants where we talked about the root hairs, how our root hairs are adapted to their function. We said they are slender, they are small, they are flexible, they are numerous, and we said all of this is to do two things. First, to reduce diffusion distance and to increase the surface area over which diffusion can take place. The same thing is with the capillaries. They are numerous to increase surface area over which exchange of materials can take place. Someone has to say something. Who wants to say something? No one. Okay. Just wait. Okay, it's back. That's what I wanted here, so that I can see who is talking. Just a moment. Okay, so we are saying they have direct contact with tissues for efficient exchange of materials. They are numerous to increase surface area over which exchange of materials occurs. They are one cell thick. I told you all these adaptations are to carry out two functions. The first function is to reduce diffusion distance, and the second function is to allow efficient exchange of materials, or to increase the surface area over which exchange of materials can occur. I'm pausing here to ask the question. How many of you did the question bank here I told you? How many people did that here? Mugondesha, did you do my work? You people did. Who did the year I told them to do? Because I have the guide. I have the marking guide. I can't run. Or after the lesson, you just switch off your phones. You just go to WhatsApp until the next lesson comes.
Section A.
You did section A. You had a full week. What failed you to do the other part? And you also?
I also did the graph.
You also did?
The graph.
What about the rest? Send it to me in my inbox. What about the rest?
In the book.
No, send the pictures. Korean, you hope. You are saying?
I tried.
Yeah, I don't know where you tried. Show me where you tried. Nambuya boy. Yeah, take pictures, send me. Nambuya, Akantora, Nakedi, Mutebi, Navatars. We just like chewing people's money. Please, let's do these things. We can finish the question back before you even come back to school, if you are serious. Okay? Let's go back to our lesson. I was talking about the adaptations of capillaries. I said they have a thin lumen to increase the pressure to allow materials to diffuse out faster. Let me explain. How many of you have ever washed a car using a pipe, piped water, and then you squeeze the front part of the pipe so that water comes out faster? What you do is you are changing the size of the lumen through which water is passing. When that happens, water which is already in the pipe has to force itself through the narrow lumen that is in front. And that pressure that is generated is what results into ultrafiltration. We talked about this in next question. Ultrafiltration is filtration using pressure. We already said that capillaries are one cell thick. And because they're one cell thick, they behave as a semi-permeable membrane, meaning they can allow some molecules to go through and other molecules will not be able to go through. Now, what does that imply? That implies that as blood is flowing from the arteries to the arterioles to the capillaries, the increase in pressure that is built, that increase in pressure that is generated is going to push some molecules out and is going to leave other molecules out. But we shall come back to that a bit later. Let's finish this. So, what is the mechanism of exchange? First, we said that capillaries run close to the cells, and because they have a small lumen, there's a pressure difference that is generated. Because they have a small lumen, there's a pressure difference that is generated. This pressure difference here we are talking about, what does it do? The first thing is it forces small molecules like water, like nutrients, like hormones, ions to move out of the water. Just like what happens when you're doing ultrafiltration in the kidneys. Small molecules are pushed out at the glomerulus due to the difference in pressure of the efferent arteriole and the glomerulus body of the capillaries. These small molecules that are pushed out result into what we call the tissue fluid. So what are some of the molecules pushed out? We have water, and I need someone to explain this. That's why I'm taking my time. Molecules move out by pressure. They are pushed out. And what are some of those molecules? We have water, we have hormones, we have ions, we have nutrients. Every small molecule, like glucose is pushed out. And now, as a result, what remains inside the blood is very, very concentrated. What remains inside the blood is very concentrated. And remember, we said osmosis, movement of molecules from regions of high concentration to regions of low concentration across a semi-permeable membrane. And even diffusion, movement of molecules from regions of high concentration to regions of low concentration. So what happens is, because the blood that remains in the capillaries remains very concentrated, some of what was in the tissue fluid, in the cellular spaces, diffuses back into the capillaries. Diffuses back into the capillaries. Now, we have to understand that this is done to maintain a balance. It is done to maintain a balance. In what way? If all the molecules that are pushed out are filtered at the arterial end, do not come back into blood, we are going to have very concentrated blood, and we are going to have what we call edema. Have you seen pregnant women when they sit and their feet begin to swell? That swelling is as a result of this filtration. A lot of water is pushed out of the capillaries and it does not go back into the bloodstream. However, it's not all bad. Why? Because even nutrients diffuse into the cell. And we said here that the wastes in the cellular spaces diffuse back into the capillaries. So it's not all bad. However, if it is not maintained or controlled at an equilibrium, we will have issues very soon. Now, here is the first assignment we are all going to do. It's a simple one. We are going to draw the organ that pumps and receives blood from all body parts. And that is the mammalian heart. What can I say about it? Unlike the fish heart and the amphibian heart, the mammalian heart has 4 chambers. While the fish heart has 2 chambers, 1 atria and 1 ventricle, the amphibian heart has 3 chambers, 1 ventricle and 2 atria. The mammalian heart has 4 chambers. It has 2 atria and 2 ventricle. Of course, loosely speaking, those are 4 chambers, but they are really 2 chambers. What divides them are the valves in between them, the tricuspid and the bicuspid valves. Okay, so we need to appreciate that. And your first assignment, all of us have agreed, is going to be drawing the organ that pumps and receives blood from all body parts, and that is the heart. So you draw and send it to me in my chart, and I tell you if it is correct or it is lacking something. Now, how is the heart adapted to its function? Because the heart is one of the most vital organs of the heart. In fact, some of you fall in love with your heart instead of using it to pump blood. Like who? People like Ampad the Thanks. You're out here falling in love with your heart, and when it breaks, you begin getting diseases. Your heart is for the purpose of pumping blood and not anything else. However, how is it adapted? Not for love, but for pumping blood. The first thing it has is it has what we call a pericardium membrane. Now, the pericardium membrane secretes a fluid that lubricates the what? The heart. And it reduces friction on the walls. It secretes a fluid that lubricates the heart walls and reduces friction. Because, guys, we have to appreciate that the heart works not only when you are awake, it keeps working even when you're sleeping. Some of you snore, some of you sleepwalk. Your heart is always working. But how is it able to do that without ever getting fatigued? We are going to get to that point. It has valves which prevent the backflow of blood. I've already mentioned 2 of them, the tricuspid and the bicuspid valves. I'm mentioning a third one, the atria. What are they called? The atrioventricular valves. I hope I'm right. No, they are called. What are those other valves called in the heart? I'm forgetting them. Someone remind me.
Semiluna.
Someone is saying I am so fast, but I've only done 8 slides. You pay attention. I'm repeating some things so that people do not get left behind. Okay, is that Mutebi Brian? Mutebi.
Shadai the same.
The what?
Semilunar valves.
Yes, the semilunar valves. Thank you very much. The semilunar valves. So we have the semilunar valves, and we have the atrioventricular valves and the atrioventricular valves. Sorry, the bicuspid valves and the tricuspid valves. Those valves prevent backflow of blood, maybe from the aorta or from the atria or the ventricle. Depends where the blood is, but they prevent backflow of blood. It contains cardiac muscles. Now, these cardiac muscles are what make the heart special. Otherwise, it would be like any other muscle on your leg. But what the cardiac muscles are genuinely special for is this. They contract and relax without fatigue or requiring nervous stimulation. Not to require nervous stimulation is what we call being myogenic. So we are saying here our heart is made up of cardiac muscles which contract and relax without fatigue. They don't get tired. From the day you are formed in your mother's womb, 2 things form first: the brain, that is the central nervous system, and the heart. Your heart begins working, it begins pumping until the day you die. Like some of us who are going to die at 120. Okay, my heart is going to pump for 120 years without getting tired. Some of you, it will pump up to 30 years. Depends if you are in people power, it will pump up to 20 years, and so on and so forth. I believe some of you are almost making 20 years. This lockdown is not easy for us. But what is the point I am making? The heart is made up of a type of muscle called the cardiac muscles, which contract and contract without actually ever fatigue. What is fatigue? Let me explain. If you have ever run 100-meter race, they have just told me he have used 90% of my daily 300 MBs. We are in trouble. I'm saying, what is fatigue? If you've ever run 100-meter race, of course some of you can't. Let me see here who can't. Nabatanzi can't, Korenyi can't, Akantola can't. The reason you can't is that the reason you can't is because your muscles fatigue very quickly. Your muscles get tired quickly. And it is not that they don't like to run, but it is because you've not practiced running that long. Now, the heart does not have that problem. For it, it keeps pumping. It does not get tired. The muscles keep contracting and relaxing, contracting and relaxing. It will keep doing that until the day you die, until they announce you brain dead. The heart will keep pumping. And the heart pumps minus myogenic stimulation, minus nervous stimulation. Let me explain. Have you ever wondered how a mad person does not die? Because I would have thought that when I was young, I used to think, okay, why does the brain of that guy just tell the heart to stop pumping? The reason the heart of a mad person continues to pump, even when they want to kill themselves, the reason why you can't just say in your brain, now I want to kill myself, is because your heart does not depend on your brain for pumping. For it pumps even if the brain knows it or the brain does not know it. Look at people who are in a coma. People who are in a coma, the heart can keep pumping, but the brain is not working. The brain maybe is in a very, very subtle state. It's not being even sensed, but the heart is pumping because the heart pumps. It can be, of course, the brain can tell the heart to increase speed, but it cannot tell the heart to stop pumping. I told people you cannot kill yourself by holding your nose. So you cannot hold your nose until you die. Why? Because the brain and the heart are different areas of work. The heart works alone and the brain also works alone. However, this is not entirely true because to some extent the brain can tell the heart to slow down, and then which we call the parasympathetic nervous system, and then the heart can also tell the brain can also tell the heart to quicken up, to pump faster. For example, if you find a thief, if you're being chased in a dream, if you're being chased by a dog, we talked about that in coordination, that if you're being chased by a dog, the adrenaline is released in the blood, which causes the heart to pump faster, the eyelids to widen, it causes the pupils to widen, causes your hairs, your erector pili muscles to contract, causing hair to stand on the skin. All those changes are affected by the brain. They affect the heart to some extent, but I want you to maintain this, that largely the heart is independent, what we call being myogenic. The heart is divided into 4 chambers, where the right part of the heart is concerned with pulmonary circulation, and the left part of the heart is concerned with systemic circulation. What is pulmonary circulation? Pulmonary circulation is circulation of blood to the lungs. Pulmonary circulation is circulation of blood to the lungs, while systemic circulation is circulation of blood to the body systems, the organs, the brain, the kidneys, the liver, the digestive system, the muscles, and so on and so forth. So it means that blood pumping to the pulmonary, to the lungs, cannot be pumped at the same pressure as blood being pumped to the rest of the body. Why? Because there's a pressure difference. There's a pressure difference. As you can see, there's a distance difference. That blood going to the lungs is traveling for a shorter distance, while blood going to the remaining part of the body is traveling to a far distance. And how is the heart adapted to carry out this unique function? It's here. The left ventricle has thicker walls to exert pressure and pump blood in a systemic circulation. Okay. Let me go back. I skipped something. Yes, we are here. The heart is connected to blood vessels which deliver and bring back blood to the heart. The heart is connected to blood vessels which deliver and bring back blood to the heart. It has a muscular septum. When you draw the heart, like I've told you in your assignment, you will see that the septum is the wall that divides the right part of the heart from the left part of the heart. It does a great job. People who have heart problems, of course, there are very many different heart problems, but there are people who have a problem with their septum, that they are born with a hole in the septum. What that does is it causes blood to mix up, like in a toad or in a frog. So when this person becomes active instantly, some of the blood coming from the body mixes up with some of the blood coming from the lungs. That mix up means the blood delivered to the body is not purely oxygenated blood. And as a result, these people have a deficiency in oxygenated blood in their body. As a result, some of them don't grow to maturity, some of them suffocate, some of their cells die. They do not grow to become very healthy people because of that simple problem of the septum having a puncture in it. Of course, it has solutions. You can do heart surgery and solve it, but that's not the topic for today. We are saying it has a massicular septum which separates oxygenated and deoxygenated blood. We are saying it is joined to a strong aorta to deliver blood to the rest of the body. You will see that the aorta is a very large vessel coming from the heart. It divides into three. One of them goes to the brain, one of them goes to the skin, and the other goes to the systems of the body. But these are very large veins. The heart has pacemakers. I want you to read about this, the heart pacemakers. I want you to be good students. Read about it. Let me give the assignment to someone. Ampad de Sanksi. You're going to read about the heart pacemakers. Natural, the heart pacemakers. Write them down. San and AVN. Let me send you a message. Sayano.
The heart pacemaker.
Yes. The sinoatrioventricular node. And AVN. Go and research about them and tell us what you find out, okay? Let's go back here. So the heart has pacemakers that regulate the pumping mechanism. Instead of the heart just pumping for same pace, when you need to run, the heart will pump faster. When you're sleeping, the heart will pump slower. When you're sick, the heart will pump differently from when you are healthy. When you are fat, your heart pumps differently from a person who is thin. All those differences are generated because of the ability of the heart pacemaker. So this is the second assignment I want people to do. I want you to tell us the mechanism of the pump. To describe for us. I want you to describe for us the mechanism of pumping that the heart uses. How does the heart do its function? Okay, so you're going to tell us the process of the pumping action of the heart. That is the second assignment. We are writing it, the process of the pumping action of the heart. The process of the pumping action of the heart. I have given you 2 slides there to copy from. Undergoes diastole and diastole process. Okay, so there are 3 assignments I want to do today. So let me reiterate. The first assignment was to draw the mammalian heart. The second assignment is to describe the mechanism of the pumping action of the heart. The third assignment is to draw the circulatory system, the mammalian circulatory system. The first one is to draw the mammalian heart. The second one is to describe the mechanism of the pumping action of the heart. And the third one is to draw the circulatory system. Give me a thumbs up if you understand what I have just said there. Mutebi is putting up his hand. Yes, Mutebi. Yes, Mutebi. use the symbols well. So we are remaining with 5 minutes in our lesson. So let's recap what we have talked about. Kedi, what have you learned today?
Teacher, I've learned that the heart is independent and does not need assistance from the brain to function.
Thank you. Kantora na Joy. Nyabaga mamdekeko kamera. Akantora na Joy. Koreni Hope, what have you learned today?
Teacher, not me. Teacher,
Yes.
we have learned that without the septum, we would all be having problems of blood mixing.
That is true. That is very, very true. The septum prevents our heart, our blood from mixing up. It's very important. It prevents oxygenated blood from mixing up with the oxygenated blood. What? Nachibirango Tendo.
Yes, teacher.
What have you learned?
Teacher, I have learned the differences between the artery and the vein.
Tell us some.
The artery has thick muscular walls, while the vein has thin muscular walls. The artery has a narrow lumen, while the vein has a wide lumen. The artery has no valves, and the vein has valves. The arteries transport oxygenated blood except the pulmonary artery, and then also the veins transport deoxygenated blood except the pulmonary vein.
Wonderful, wonderful. Keep that in mind. Nambuya Beth, what have you learned today?
Teacher.
What have you learned today?
I've learned that adaptation of capillaries.
Fire away.
Slow movement of blood in capillaries makes exchange of material efficient. They have a large surface area of exchange of materials. They have thin walls of faster diffusion of material.
They have thin walls for faster diffusion of material. Thin walls for faster diffusion or to reduce diffusion distance of the material. Mutebi Brian. Mutebi Brian. So far, Kantora Najo and Mutebi Brian, I've not said anything. Hey, Mutebi speaking.
Sir.
What have you learned today?
Adaptations of the heart to pumping blood. Sir, you said the heart has valves which prevent backflow of blood, and you said it has an enclosed pericardium membrane.
An enclosed
pericardium membrane.
It is enclosed in a pericardium membrane.
Yes.
Continue.
You also said that it is divided into 4 chambers, whereby the right is concerned with pulmonary saturation, as the left is for systemic saturation.
Amina. Thank you. Mugondesha, please. Mugondesha, please. What have you learned today?
Yeah, like teacher, I've learned about like what you said about the heart, that it's too strong to stop beating. Actually, that's what I've actually learned because I came to the lesson late, a bit late, and also my
Gondesha, you've been here since the lesson started. Don't lie us. Who was on the phone? Okay, I'm bad the thanks.
Seriously.
Apart the thanks, what have you learned today? Lisa Chironde, you're welcome. We are finishing up.
Yeah, thank you very much, Mr. Solomon.
Okay, sir. Apart the thanks.
I've actually learned about capillaries. Capillaries, first of all, they have thin walls. They have elastic vibes. And
Wanji?
teacher, I continue.
Yeah, we are waiting for you to continue.
Yeah, capillaries have the largest lumen. They have no valves to prevent the flow
Are you
of
sure
blood.
they have the largest lumen? They don't have the largest lumen. They have the smallest lumen. Check your notes very well. Thank you. Nabatanzi.
I've learned that the heart is independent and the adaptations of the heart divided into 4 chambers, whereby the right is concerned with the pulmonary circulation, and the pulmonary circulation is circulation of the lungs, and systematic is circulation of the body system.
Okay, thank you. So guys, we are not trying to cover as much. We are not running through this, but we are trying to put understanding to it. Let us do the year that I told you guys to do. You do section A and section B. Send me the pictures in my inbox, and then I'll go through them and give you the answers. Otherwise, next week we are starting 2017. Find time and do it. And when you do it, ask me for the marking guide. Have a great day. Bye-bye.